Well, hello friends. Welcome back to the program. Today we are going to work on some animation stuff in Windows Server. And I would like to add a new animation, much like we already have the minimize and restore animation. You see that there's an outline of the window coming in and out as we minimize and restore. I'd like to have a similar animation when we double click on something here on the desktop and a window pops up as a result. I think it would be cool if we would start the same type of animation as we do for minimize restore coming out of the icon here. So like it would expand from there somehow, like a wireframe of the window. And there's a whole bunch of steps to this. So I think we'll have to start in Windows Server because the minimize animation is kind of, it's very specific to minimize animation. It's this thing that we haven't made like a generic animation mechanism or anything like that. And basically the compositor, let's go look at that actually. The compositor drives the minimize animation very in a very specialized and specific way, that there's this thing called render animation frame, which is called every time that we compose the screen, so 60 times per second, we just iterate through the window stack and drive, if the window is in the minimize animation, then we drive that animation here and do like rectangle interpolation and stuff. But this is like not very friendly to adding more animations. So I think we're going to have to reorganize this code a bit so that the compositor doesn't know it specifically about minimize animations, but it would just know about animations, and it can drive sort of a set of animations that Windows can then register to do whatever they want, basically. I'm not exactly sure how it should work, but we'll figure something out. And also I wanted to say that I think the window animation, here. So it has a number of steps. This is very unsophisticated. We just, we take 10 steps from when we started and then the animation ends. And since we draw at 60 fps, it's every 16.66 milliseconds, right? So you get effectively 10 frames at that speed. So that's 166 milliseconds or whatever. And I think we can definitely come up with something nicer than like, oh, this animation runs for 10 frames. Like it would be much nicer if we could say like, oh, this animation runs for 200 milliseconds or 1 second or things like that. So that's also something I would like to improve. Let's just start somewhere, maybe by adding an animation class. Seems fine. And then let's go ahead and add it here as well. Animation.zip. Okay. Yeah, that feels like the logical place to start. So animation, and let's make sure that we have the right dates. So what is an animation? So I haven't written a lot of animation code in my life, and all of it has been very unsophisticated. So if we think about, let's try to be a little bit more sophisticated. So instead, what we were doing previously is just having like an animation cycle through 10 steps, and then like draw itself at each of those steps. But instead, I would like the animation to have a specified length and time, and then whenever we end up drawing as a result of the animation firing, we would compute like the exact appropriate state to draw at that time, so that you have like I guess like a smoother, more time correct animation, so that like if you get a delay in the middle for whatever reason, the animation adapts and doesn't lag just because there's a delay. Yeah, so let's see. What do we have on this thing? It's like set length, maybe? Length in MS. And maybe we'll have a getter for that. Length, let's say. And then we can use we have this class called an elapsed timer, which is a timer that you can start, and then you can ask it, how long has it been since I started you? I think that will be perfect for this. So we'll just call that timer. Since we don't need to have sort of an event loop timer to drive this thing, we're just going to drive it from the compositor anyway. If we try to drive this from the event loop, that would kind of be unnecessary because the compositor knows when it's a good time to draw. So better to just drive it from there. And then I think the compositor will have sort of a set of these, like a hash table of animation, maybe? Animations. So we'll just forward declare. And then let's allow the animations to register themselves. So with the compositor, like this, right? So then the compositor can just iterate over the animations when it wants to draw the screen. So we would have in compositor, there would be something like update animations. And here there would be something like animation update. Maybe we pass in a batch of compositor so that nobody else can update these things. Yeah, that's actually really neat. Okay, so compositor, and then compositor.h, of course, needs to have that update animations thing. We'll just put that inside here. And the old animations code, I think let's just not try to fix it up to be nice. We can just probably just replace it with this. I don't particularly suspect that there's much of value in that stuff. Okay, so now we have an animation class, and let's go ahead and flesh out some of the members. So animation.h. Namespace, Windows Server. All right. So just the basics first. Cool. And then animation update. Compositor. Oh shoot, I guess I need act forward for that. Yeah. Okay. Act batch. And what do we do when an animation is updated? So this will be called approximately 60 times per second. So I guess we want to render, I think. So like, maybe we will, let's see. Let's have a start and stop API. And then maybe also like Google is running. Something like that. Yes. Okay. So start, stop, what do they do? Start, we'll just say running is true, and timer start. So this is the elapsed timer that we start here. And then whenever you query the timer for its elapsed amount, it will give you the number of milliseconds since we called start. So we'll be able to use that in the update thing here. So let's see, elapsed milliseconds is mtimer elapsed. And then that tells us the total progress. Elapsed milliseconds divided by the length. Right, so yeah, I think that makes sense. And then like we can say whichever is smaller of this or 1, because you don't need progress above 1. Okay, and then we can call somebody. Maybe we should have a hook. So like function on update, maybe, with the progress. That's kind of cool. All right. So if on update, then we call on update with the progress. And then I guess if the progress is 1, then we stop the animation. Yeah, because we don't need to support repeating animations maybe at the moment, at least until we actually have a use case. Let's not think about that. So what does stop do? Stop simply says running is false. And maybe we'll have an on stop thing as well, so that you can register what you want to happen when you stop. Okay, that looks sensible. Okay, and then how do you use this? So let's see, what do we want to happen? Let's just create one of these things in the window. In the window class, I was saying. Let's give him an animation. So like own footer to animation, minimize animation, perhaps. Maybe there should only be one animation allowed. Actually, I mean, a window should only be doing one animation at a time. So that, I feel like that makes sense, that you only have one animation. I think. Let's see. So then when you start the minimize animation, let's do something. So we'll leave the old code there. And then we will also do animation is make animation. Make animation. Set length is going to be, well, I don't know, let's make it like 1 second. And on update, let's do something like, let's just print out like animation update with the progress. Animation on stop. Stopped. Stooped. And then we'll finally start it. Okay. Let's see how that goes if we just try to build and run that. Wait, did I add any code to drive these? I feel like I forgot that. I wrote the thing in compositor, but nobody calls this. So let's just call this when we compose. Where do we drive the current animations? I think at the end. Right, step animations. Yeah, so here let's do this. Update animations. Or wait, this should actually be done before we flush the screen. Wait, what is this? Step animations. Oh, so we render animations up here. Oh, interesting. Okay. All right. I see. So update animations. Let's see. We don't care if they rendered or not. But I guess we do have to pass in. What does this do? Render animation frame takes a screen and a flush rects, and then potentially draws and, oh, I see. Right. So the way it works today is that the compositor asks this function to render any ongoing animations. And if rendering the animations resulted in some part of the screen needing to be redrawn, the rectangles that need to be redrawn are added to this flush rects thing here. So I think we want to do the same thing for our update animations, so that it can know, so that it has a place to put like anything that needs to be redrawn. So let's just go ahead and include that in the signature. Update animations. Render animation. Yeah, I don't know why I still have both of these. Okay. I think when we're finished, we can just erase the old code, but let's see. Disjoint rect set. Okay, so I think these are unused, but maybe we should just pass them on to the animation function. And then it can, whoever is the callback for this thing will be able to have the screen and the disjoint rect set for damage rects or invalidation rects. Disjoint rect set. Flush rects. So these should probably be part of this thing as well. And then, okay. So screen. Not interact. Disjoint rect set. Disjoint rect set is one of the first classes I remember feeling was like a real hassle to implement in Serenity. It's basically, it represents a set of rectangles in arbitrary formation with the invariant that none of them overlap. So you can keep adding any arbitrary number of rectangles to a disjoint rect set, and it will keep like splitting them so that there are no two overlapping rectangles in the set. And this is used to implement compositing, where it's an issue if you ever draw the same rectangle twice and you have an alpha channel. Then, like, if you draw semi-transparent pixels twice in the same area, then you stack, you end up like sort of increasing the intensity of the picture in that position because you're drawing with an alpha value that's not 1 or 0. Anyways, getting off track, but that's what that is about, disjoint rectangle set. So it's very, very useful data structure for storing the invalidated rectangles on screen. Flush rects. Okay, so now we pass those along, and then on update, we'll get the screen amp and the graphics disjoint rect set. We don't have to do anything with that. We can just... I just want to run the code and see that it prints something out when we animate. Oh, we forgot to do set length. I feel like that doesn't need to do much, but... I mean, it just needs to assign the length, right? We don't have to get fancy, at least not right now. So let's see. Oh, look at that. That's not working right at all. Oh shoot. Did I remove the code that was step animationing? Step animations has to be called at the end of compose. I probably removed that without thinking, did I? Looks like I did. Yeah, step animations. But we didn't animate the other thing because we forget to call compositor. We added a registration function, but we didn't call it. Register animation, batch this, star this, and likewise unregister on destruction, and then we are missing implementations of those, so let's just add them. Compositor, register animation, animations, set animation, and we can verify that it was added. Inserted new entry, yes please. So that you don't insert the same thing twice, that would not be good. And likewise, was removed is animation, remove animation. Verify was removed. Yeah, let's just be good and careful. Oops, what did I do? Wait, what the heck? That's so weird. Why is my QEMU suddenly in scaling mode? That's so weird. There have been a bunch of changes to the way we run QEMU in the last couple of days, but this is so weird. I don't know why it does this. It's supposed to start up in the full resolution at 1x size. That's weird. Anyway, let's just ignore that and do this. And now we got all these animation updates here. Yeah. So printy, 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 and then suddenly we get a 1 and then it stops. Wait, what? Wait, did I put that in a weird way or something? Why does that code look so uneven? Update animations. Render animation frame, update animations. So it paints very often, actually. Or, well, it's weird because like it makes these small steps of progress and then it makes a bigger step towards the end here. But I'm guessing that's because the system became busy towards the end. Or I'm not sure actually why it would do that. But as we can see, it does like drive that animation. Albeit in a strange way. So anyway, let's continue with this. So after it stops, we do need to like stop calling it so much. Also, wait, why are we... I think maybe we're coalescing the screen updates so that if nothing is repainted on screen, we don't recompose, but... Oh, yeah, right. So if there's nothing painting on the screen, we're not going to repaint. So this thing here, like the clock, will cause a repaint, but the animation itself does not. So if we want screen refreshes to occur, yeah, you can see that it only updates when something on the screen changes. So if we want screen animations or window animations to pump more often, I think we're going to have to like invalidate the screen a bit. But that's fine. That's fine, because that's what we're going to do in our animation callback, actually. Yeah. I don't know why I am thinking about this all backwards. I think I'm just mixing up the two animations in my head. Like we have the old window animation, which runs first, and then I made the other one much longer. So set length and ms. Yeah, so it's like 1,000. That's a whole second. Okay, I'm confusing concepts and making a mess in my head, so let's simplify this by getting rid of the old animation. So we'll just take this code here that renders the old animation, and we will copy that, delete it from compositor, delete step animations, goodbye. Yes. Goodbye. And then we will go here and put that code in the animation callback in the window class. So the code that was previously rendering the animation in compositor is now here in the onUpdate callback on the animation that we create. So let's see, let's capture this. And painter. I guess we should maybe pass it a painter as well. Wait, do we need the screen for anything? Maybe we do. But the painter is a bit awkward, so let's just pass that from the compositor. Update animations. Yeah, we'll just pass it along like screen and painter. This will be just right. And okay, so now we have the, wait, where am I? We have the painter. We have the progress. We don't need to iterate through the window stack because we are in a specific window here. We don't need to figure out if we rendered or not. We don't need to figure out if the animation is running either. Let's see. We don't need window because we are window. Okay. We do have the flush rects there, right here. Invalidate screen, compositor, the invalidate screen, sure. Screen rect. Oh, we did maybe need the screen. Well, that's very nice. Okay, so we have it. Okay. And so now we just have to take the from rect, which is where we were animating from, and the to rect, and then interpolate them into a rect at the given progress, the given current progress of the animation. So previously we would just look at like which step of the animation are we at. So this would go from 0 to the maximum steps. But now we have a float progress, which is between 0 and 1. So instead what we want to do here is like auto rect is interpolate rect from rect to rect progress. Something like that. And then we just have to figure out how to interpolate rect. So from rect to rect and float progress. So I guess like the distances or the deltas. First we'll compute the deltas. So like dx for delta x, say. To rect x minus from rect x. Yeah, I think we can do this. And then okay, and then what do we do with these boys? We start with the from rect and then add these numbers to each of the things. So we add these numbers times the progress. So graphics in rect, and then like from rect x plus like float dx times progress. This feels like it should work. All right. Wait, what's wrong with my thing? Oh, this is not used. Wait, do we need the capture for anything? Yes, we did. Okay, yeah, of course. So it's not obvious to me why C-Line doesn't like it. No match for operator. This and that. Do I have the wrong set of arguments? On update. Progress screen painter disjoint rect set. Oh, I did have the wrong arguments. Painter goes before the screen. Well, that was silly. Painter goes before the screen, no big deal, and we are good. Compositor needs to have the painter before the screen, sure. Okay, what a silly problem. Oh, look at that. Okay, so now we have the new animation code running, and as you can see, it runs for a whole second. And then it says stopped over and over. I guess we should do something when it stops. Maybe we should, I guess we should actually just like get rid of it. I don't think we can do that while the function is being invoked unless we make animations reference counted, which is a bit of a weird solution, but it does actually solve this issue. So I'm just gonna go ahead and do that. So we'll do this. We'll add a helper. So create. Yeah. New animation. Poof. There we go. That's really nice. Okay, and then instead of make, this guy just has to do animation create. So I think that means that when the animation stops, we'll now just null it out, which means that it will get removed. Although, is that going to be crashy? I feel like that might be crashy. Yeah, that's crashy. Because we need to make sure that we're holding on to the animation from the compositor while we're firing the final callback. So in update animations, we can just do something like this. Is that not possible? Okay. Yeah, there we go. So obviously, like, if the animation is this long, it's a bit like, it's too long. Also, it looks weird that the window pops up like before the animation finishes. And I think even if we use a shorter animation, I still kind of want the window to pop up right away, because ultimately, like, that does make the system feel snappy. So it's almost like a little visual trick or whatever, that we will animate the window coming in, but it will also pop on screen immediately. But because the animation is so fast, then I feel like it doesn't really cause an issue. But I'm not completely sure. Let's get rid of the minimize animation step, whatever. All the old minimize animation code we can just yoink out. Yes, okay. So what does this do now? Yeah, this is clearly too long. So let's make it like 200 and see how that feels. Yeah, so you see that this, even though the window comes up right away, it feels like it doesn't, like it's not a problem that it comes up right away, even though the animation is not yet finished. Would it look better if it didn't come up right away? I don't know. It might look better, but it might feel worse. At the moment, it seems to me that this is the better option, that it's as fast as possible, but we still play a small animation. Now the animation now is, I guess, a little bit longer than it was previously. So let's bring it down to about where it was previously. So previously we had 10 frames at 16.6 milliseconds per frame. So let's just bring it down to 150 milliseconds. And look at that. So yeah, so now we have essentially gone back to what we had before. I think this is close enough and really nice. So let's do our first commits here. Yeah, I think so. This can be our first commits. Replace, add, replace, window minimization animation with something generic, or make window, or make animations. Add a more generic mechanism for animations. This patch adds the Windows Server Animation class, which represents a simple animation driven by the compositor. An animation has a length in milliseconds and two hooks. One that gets, alright, let's see. On update, called whenever the animation should render something. On stop, called when the animation is finished and or stopped. Yeah. This patch also replaces the old window minimization animation code, or let's say ports the window minimization animation to this new mechanism. Yes, so that's pretty nice. Okay, then let's see about the other thing I wanted to do. So like making new windows, like if I double click on text editor, it would animate out from there. So if we go in the, I guess where we spawn stuff in the file manager. So applications, file manager. Wait, that wasn't right, but okay, well, it was in directory view anyway. Spawn. Right, so this is where we launch something. So who calls this? This is where like we spawn an executable. And it's done here. Here. So I feel like we're not always going to maybe have so we could start from the we could start from the icon that you're clicking on, but I'm thinking we could also start from the mouse cursor. I guess that is an option. Because in some cases, it could be hard to figure out what is the rectangle of the thing that you're trying to launch. But let's see, handle activation. So here we do have a model index. So we could probably like launch origin rect, let's say. And if the current view has a content rect, wait, let's see. Let's figure this out. So it can be the current view content rect for the index. That's in view coordinates. So translated wait, how do we get that content rect? Can we get any other kind of rect? Do we have widget rect? Content rect for the index. And then widget to widget rect. Okay. And then we have to make it into a screen rect by translating it based on the screen relative position of the view. So screen relative rect of the view dot location. I think that's the launch origin rect. Wow, that was a mouthful. Let's see. Let's see what it says if we just print out that rect. Yeah, so we have this rect right here. Feels like that could be the text editor rect. Wait, this thing doesn't print. Are we taking a different code path for... Oh, I feel like somebody... It's here, yeah. So we take a different code path for directories. If we're double clicking on a directory and we are on the desktop, then we do a launcher open instead. Sneaky. Okay, well, let's just focus on this one code path right now, because figuring out how to do this via launch server is going to be a different thing. So let's just focus on this one code path. So what if we want to communicate this to the program that's starting? So let's just set an environment variable, maybe. I don't know, like libgui. This will be a little bit maybe a little bit hackish, but it's also okay. So we'll just say like libgui launch origin rect. Also, let's make a string builder here. So builder append, or no, wait, we don't need that. We can just make a string on the fly. So let's do something like this. So it's easy to parse on the other side. Okay, oops. So we'll set n. Do we need dot characters? And yeah, there we go. and then that has been set, and then we can actually unset end when we come back because why not? Okay, so GUI window. So then in GUI window, when we create a window for the first time, or wait, how should this work? When we, the first time that we open a window in an application, so when we tell the Windows server to create the window, we can just pass it along, actually. So yeah, so we'll have a launch origin rect. And we'll pass that in as the last argument to create window. And we'll do something like this. Is that what I called it? I'm already forgetting. Launch origin rect. Split view, split add comma. And let's just verify part size is, or no, hold on, wait, let's not be unreasonable here. If part size is 4, then so parts 0 to int value or 0. Yeah, this will work. Oh, of course I have to update Windows Server IPC. Should this be part of creating the window? I mean, it feels reasonable to do it as part of creating the window. Because you don't want to do it after creating the window, because by then it's too late. Yeah, let's just put it here. Launch origin rect. Create window. Well, let's put that on a line like that. Even though it looks weird, let's do it. Okay, so now we might have an empty launch origin rect, but we might also have a non-empty one. So I'm thinking that let's see, if launch origin rect is non-empty, then window start launch animation. Yeah, that's what we'll do. Start launch animation with the rect. Okay. And I guess this will be very similar to the minimize animation in nature. So we'll make a new animation. Let's make it a bit longer just so we can look at it. And the from rect in our case is the launch origin rect. So we always interpolate from that to the, actually let's capture that. So launch origin rect to the window frame rect. It's almost like we should generalize this even more so that we don't have to have this duplicate looking code. But I think this is still a good first step. So notice, of course, that we're using the same animation smart pointer member here because we don't need to support multiple, like both of these animations running at the same time. That doesn't even make sense. What did I mess up? Probably that. Okay, so let's open something. Oh, look at that. Oh, that's so cool. Oh, yeah, right. Because of the different code path for folders. But that is really cool. Of course, it is too slow, but it looks really neat. So let's speed it up. Let's make it 150 as well. And, you know, maybe this could actually be like an animation from a frame, from one frame location to another, instead of being like customized to this level. At the moment, though, I'm comfortable with the duplication at the moment, just because I don't exactly know how we're going to abstract this yet. But I'll probably think of it next time I'm in the shower or something. Yeah, look at that. That's so cool. Cook. Wait. If I open that thing, just thinking, do these? Yeah, that's not good. Like other windows in the same process, they also do the same thing. Oh, look, and the tooltip windows, they do that. We have to forget it after the first time. So I think here we'll just unset this. After we have done this, we will just unset. Yeah. Because we don't need to do it again. Yeah, that's kind of cool. I can't get over how cool that looks. Now I'm just wondering, like, is it better to do it like the way we're doing now, or would it be better to just start making like a 1x1 rect and start from the mouse cursor wherever it is? Because that would be like a little bit more generic. But I really like this. I don't know. Also, what is the rectangle that we're actually starting from? It's like, I feel like we're not starting from the icon, but like from the text. Yeah, I think so. I think we're starting from the text. Nah. Anyways, this looks very cool to me. So, very pleasant little thing. And I think we're gonna keep it for now. See how it feels. So let's see if we can commit some stuff here. We'll do, I think, the Windows server. I mean, everything is actually intermingled, so or we have to do Windows Server and libgui together. Let's say Windows Server plus libgui. Oh, oops. Allow specifying a launch origin rect for Windows. Launch origin for new Windows, let's say. The launch origin rect parameter to the create window specifies where on screen the window was launched from. It's optional, but if you provide it, the new window will have a short wireframe animation from the origin to the final or to the initial window frame rect. It looks pretty neat. Also, it looks pretty neat, although I'm sure we can improve it. We should mention how to pass the thing. So, in order, or GUI window, the first GUI window, or no, wait, GUI window looks for the GUI launch origin rect environment variable if set to a four component rectangle. Set it to a put your launch origin rect in there with the format x, y, width, height. Yeah, this feels a little bit hackish, but it also feels like it works, and we can figure out something better as we go, I guess. I don't know. I just yeah, I'm okay with this now. I know that we can improve it. I know that we will. I just feel like we have to like push forward in some direction to get going with this. So here we go. Put your launch origin rect in there with the format and the first GUI window created by the shown by the client program will by the app will use that as the launch origin rect. Yeah. File manager. specify a launch origin rect or pass belongs to newly to spawned programs. This makes GUI applications animate their initial window launch. Yes. Yes. This does make me wonder if we should do this with more stuff. Like if you click on open here and then it would animate out from the open button, that does make some kind of sense to me. Like I like the idea of the interface showing that like this thing comes out of that thing and that thing comes out of that thing. There's something about that appeals to me, like the desktop metaphor of it all, where you're opening drawers and stuff. I do like that. So I think we'll have to experiment with this and see how it goes. But for today, I'm happy with the progress. So let's just round it off here, I think. And yeah, that'll be it for today's video. So if you made it this far, then I thank you for watching and for hanging out. I hope that you saw something interesting here today. And I guess I'll see you next time. Bye.